Hello, I'm Lynn Bondurant, and welcome once again to our series about America's civilian efforts in air and space during a quarter century. During this program, we cover 1981 and 1982. To put 1981 into historical focus, that is the year scientists report the cloning of mammals. And in 1981, American balloonists traveled 6,000 miles across the Pacific Ocean. Meanwhile, NASA launches the space shuttle into Earth orbit for the first time in 1981.
As astronauts John Young and Robert Crippen headed for the launch pad, they represented more than being the pilots of this country's first space shuttle flight. They represented years of hard work by thousands of people and businesses, both large and small. Columbia's maiden flight was brief, just 54.5 hours, 36 orbits, and returned to Earth. But it signaled the beginning of a reusable space transportation system.
Look at the sand! Look at the sand behind it!
30 weeks later, after Columbia had been returned to the Kennedy Space Center, cleaned, refurbished, and rolled out to the pad, astronauts Joe Engle and Dick Truly flew Columbia into space again. While an imaging radar system mapped distant Earth, the crew made a critical test of a Canadian-developed mechanical arm that will be used to place payloads into and out of orbit on future flights. Even though the second mission was shortened from 5 days to 2 days because of a fuel cell problem, the crew managed to carry out nearly all major tests. As Columbia landed the second time, the circle was complete. A new generation of space travel had begun. Looking ahead to 1983 and beyond, NASA's Marshall Space Flight Center began training Space Lab crews. When placed inside the cargo bay of the shuttle orbiter, Space Lab converts the shuttle into a research center that will be used by scientists from around the world. Planned are experiments in communications and weather forecasting, crop surveys, manufacturing, astronomy, and life sciences. A mobile workstation, a concept developed by NASA's Langley Research Center, was tested underwater at Marshall's Neutral Buoyancy Facility. The mobile workstation may be used by future astronauts to construct large platforms or antennas in Earth orbit. It allows a pair of pressure-suited astronauts to move horizontally and vertically and build systems that are too large or complex to fold up and transport aboard the shuttle. As Columbia took its place in the history books, a small unmanned spacecraft, Voyager 2, made its mark 1 billion miles from Earth. Voyager 2 approached and passed by the planet Saturn and its 17 fascinating moons, taking thousands of pictures and making detailed scientific measurements as it went. Those music-like sounds occurred as tiny particles hit and bounced off Voyager 2's plasma wave detector antenna. Saturn's vast ring system is made up of many small particles that orbit the huge planet in wave-like patterns. One instrument on board Voyager 2 actually measured the thickness of Saturn's rings and found that the edge of the main ring system is remarkably thin, less than 500 feet thick. Its atmosphere is dominated by a strong equatorial jet stream that blows eastward at 1,200 miles per hour. Those storm systems are something like hurricanes here on Earth and are the means by which the internal heat energy of Saturn may feed the high-speed jet streams themselves. As Voyager swept by, it detected hot gases surrounding Saturn that are 600 million to 1 billion degrees Fahrenheit, the hottest gases ever observed in the solar system. For the Voyager teams, years of analysis lie ahead. In the meantime, the small spacecraft will be watched and guided toward its rendezvous with the planet Uranus in 1986 and Neptune in 1989. Scientists have been studying the planet Venus for years, and a large number of them recently met in an international conference to compare their new findings. Apparently, there are two major volcanic regions on the thick-crusted Venus that serve as escape valves for the planet's seething internal heat. Venus clouds are upside down and are made up of a smog layer and a layer of sulfuric acid droplets that produce drizzle but seldom hard rain. During its early history, Venus may have been Earth-like, with cooler temperatures and an ocean. When the Space Telescope is launched and begins operating in 1985, it will send electronic data to a newly established Space Telescope Science Institute at Johns Hopkins University. The Space Telescope will provide astronomers with 24-hour views of the sky of unprecedented clarity. This specially outfitted C-141, the Kuiper Airborne Observatory, is operated by NASA's Ames Research Center in California. The Kuiper Observatory routinely takes astronomers and their instruments to altitudes above most of the Earth's distorting atmosphere. From there, they can examine distant galaxies and study their vast energy. Some of NASA's high-flying picture takers look down rather than up, down at the Earth, that is. The high-altitude U-2 aircraft is a good example. In addition to aerial mapping cameras, these planes carry air sampling devices to study the protective ozone layer in our atmosphere. They are also helping to locate new water sources, assess flood damage, and fight forest fires. 2 Landsat satellites continue to orbit the Earth 14 times a day. From their 570-mile-high vantage point, they return images like these taken over rich California farmlands. Telltale red images indicate vigorous vegetation growth. The state of California is using Landsat imagery to inventory and map its irrigated cropland. Not all of NASA's research has application to airplanes or spacecraft. Sometimes that situation is reversed. On a little-used runway within sight of where the Space Shuttle Columbia already landed twice, engineers are studying how to make tractor-trailers and weekend motor homes more fuel-efficient. Using known aerodynamic techniques, the corners and underbody of this van were rounded. Result, 70% lower drag with a 30% fuel savings, just by reducing the air resistance as the van travels along. These encouraging results may help change the shape of many vehicles in the future. This car can be driven thousands of miles without ever moving. Only the wheels spin to simulate driving. It is part of a program that the Jet Propulsion Laboratory has been involved in for the Department of Energy since the late 1970s. The research is aimed at making electric-powered cars competitive with those we now use for our regular shopping or commuting around town. Much of the activity this past year focused on finding batteries that will last longer and have an operating range of 75 to 100 miles per day. Since May, residents of the Pacific Northwest have been receiving some of their electricity from an old power source, gathered here at Goodnoe Hills, Washington, by the largest wind turbines in the world. 350 feet tall, with blades the length of a football field, the 3 computer-controlled turbines represent the first wind farm, a cluster of wind generators working together to act as a single power source. Built as part of the Department of Energy's Federal Wind Energy Program, the trio of wind turbines are managed by the Lewis Research Center and provide 7.5 million watts of electricity to the Bonneville Power Administration, enough to power nearly 2,000 of the area's homes. NASA launched satellites for a variety of users, including a new ComStar communications satellite for the ComSat General Corporation. Also launched was the second in a series of improved weather satellites, GOES-5, for the National Oceanic and Atmospheric Administration. Another plane, the Quiet Short-Haul Research Aircraft, or QSRA, performs exceptionally well in short takeoff and landing operations. By directing its own exhaust over the plane's upper wing, the QSRA is able to improve its short takeoff and landing performance. The QSRA's simple but versatile systems permit a wide variety of flight investigations that are providing important data to the American aerospace industry. Following a hard landing from 12 feet, it was decided not to repair the X-14B vertical takeoff and landing airplane. The X-14B is really a very sophisticated electronic flying simulator and has been used as a research tool at Ames for the past 20 years. The largest wind tunnel in the world, with a test section of 40 by 80 feet, is being made even larger. 6 new 22,500 horsepower drive motors are shown here being installed in the Ames facility. When complete, the improvements will add an 80 by 120 foot test section capable of handling full-scale aircraft with engines running. It will also increase the airflow in the existing 40 by 80 foot test section by 115 miles per hour. This busy wind tunnel has been operating 2 shifts a day for the last 30 years.
So in 1981, NASA sends men back into space. During the following year, 1982, in other fields of research, scientists announced that more evidence points to the possibility that viruses cause human cancers. And in 1982, doctors used bone marrow transplants to treat leukemia. 1982 is the year of 3 more manned space shuttle launches as well.
On March 22nd, astronauts Jack Lousma and Gordon Fullerton started off on a journey that would last more than 8 days in space. As part of the test program to check out Space Shuttle Columbia's systems, the crew started and restarted the orbital maneuvering engines, turned the orbiter toward and then away from the sun for thermal testing, and successfully operated the remote manipulator arm, picking up and moving various parts of a space science payload. They also carried experiments to monitor solar flares, medical and materials processing, and the effects of zero gravity on flying insects, as suggested by high school student Todd Nelson. After 384 hours and a 1-day delay because of bad weather, Columbia landed at the Army's White Sands Missile Range in New Mexico. Approximately 12 weeks later, astronauts Tom Mattingly and Henry Hartsfield piloted Columbia on its 4th and final test flight. The spacecraft's nearly flawless performance marked a fitting end to the orbital flight test program, making it possible to certify the Space Transportation System as a fully operational carrier. On July 4th, after 7 days in orbit, Columbia made a perfect landing on a concrete runway, another first. The President and Mrs. Reagan were there to watch the landing and greet the crew. November 11th and Space Shuttle 5, the first operational flight. 2 commercial communications satellites were hauled into orbit, one for satellite business systems and one for Telesat of Canada. Their deployment was a complete success. Space Shuttle had delivered as promised. Columbia and the 4 astronaut crew landed back on Earth at 9:33 a.m. Eastern Standard Time on November 16th. Another milestone event, the completion and rollout of the second Space Shuttle orbiter, took place in July. Christened Challenger, the new orbiter is scheduled for its first mission early in 1983. Challenger traveled overland to NASA's Dryden Flight Research Facility, where it was mounted on top of the 747 carrier aircraft and flown to the Kennedy Space Center, Florida, to ready it for its first flight. Looking farther into the future, NASA has selected 8 companies to prepare space station mission studies. The studies will contribute to the development of specific mission requirements and overall architectural options, which will be incorporated in NASA studies of a shuttle-tended, permanent orbiting facility. The companies are expected to identify and analyze the scientific, commercial, national security, and space operational missions that could be most efficiently conducted by a space station. 1982 was also a busy time for unmanned spacecraft. 2 satellites for Western Union were launched, called WestStar 4 and 5. These communication satellites relay a variety of radio-television programs, as well as transmit complete editions of magazines to regional printing plants. U.S. News and World Report, Time, People, and Sports Illustrated all use WestStar. Other unmanned launches included an Anik 4 communication satellite operated by Telesat of Canada, RCA Americom's Satcom 4 and 5, and Intelsat 5. Around the country, the various elements of the Space Telescope are being worked on and assembled. At the Perkin-Elmer plant in Connecticut, the 92-inch telescope mirror has been finely buffed and polished. A wide-field camera is being built and tested at the Jet Propulsion Laboratory in Pasadena. These mock-ups of the Space Telescope's parts give an idea of its size. It's here at the Lockheed plant in Sunnyvale, California, that it will be assembled. At the Marshall Space Flight Center in Alabama, astronauts practice working around the Space Telescope in a tank filled with water to simulate the gravity-free space environment. The Space Telescope will be placed into orbit from the Shuttle Payload Bay in 1985. It's designed to be an international observatory located in space for the study of the universe and is expected to provide new advances in astronomy and physics. An infrared astronomical satellite will soon be launched from the Western Test Range in California. It's shown here undergoing tests at the Jet Propulsion Laboratory. IRAS, as it is called, is an international project that includes NASA, the Netherlands, and the United Kingdom. The new Earth-orbiting instrument with its 68 infrared detectors will be used to witness the birth of new stars and the death of old ones. IRAS will probe through space, searching for celestial phenomena that are invisible to our eyes, but glow in the infrared. Pioneers 8 and 9, launched in 1967 and 1968, and orbiting the Sun since that time, passed within 1.5 million miles of each other on October 7th. In space terms, a close encounter. They, like the 2 unmanned Pioneers that followed them, Pioneers 10 and 11, continue to return a stream of new information about our solar system to Earthbound scientists. The spacecraft have traveled billions of miles from Earth, passing safely through rocky asteroid and radiation belts along the way. These are some of the last photographs of Mars. They were taken by the Viking 1 orbiter and processed this past spring at NASA's Jet Propulsion Lab. More than 50,000 photographs have been taken by the Viking spacecraft since 1976. The 2 Vikings were launched 7 years ago. As they arrived at Mars, the lander portion of the spacecraft separated and touched down softly on the Martian surface, leaving the orbiters circling above the planet. The Viking 1 lander continues to send back valuable imaging and meteorological data every week. The 4th Earth-scanning Landsat was launched from California on July 16th. Landsat 4 is designed to continuously collect accurate information on Earth's resources, information useful in land use planning, exploration, and agriculture. An onboard thematic mapper recorded these views, which should help urban planners better manage and monitor urban sprawl into the surrounding countryside. After completing its 3-year mission, Landsat 4 is designed to be retrieved by the Space Shuttle. This is Medicine Bow, Wyoming, site of the dedication of 2 wind-powered generators on September 4th. The project is a joint endeavor of NASA's Lewis Research Center, the Department of Energy, and the Bureau of Reclamation. One unit was built by the Hamilton Standard Company and is nearly 400 feet high. It's capable of producing 4 megawatts of electricity. The second unit, constructed by the Boeing Engineering and Construction Company, is powered by a rotor 300 feet in diameter and can produce 2.5 megawatts of electricity. When operating together, the pair of wind turbines will provide enough energy to meet the needs of 3,000 homes in the Rocky Mountain area. The Lewis Research Center has been working on experimental ion-electric rocket engines for more than 2 decades. Electric engines produce minute amounts of thrust and do it more efficiently than conventional chemical rockets. One experimental electric engine, CERT-2, has been tested for 11 years and journeyed more than 1.5 billion miles through space. Ion propulsion systems are especially attractive for possible comet and asteroid rendezvous missions, exploration of the outer planets, station keeping of communication satellites, and orbital platforms. The next space test of an ion rocket engine will take place in 1983. The Lewis Center has also been working on Earth applications of solar power. For example, a solar electric-powered medical clinic has been designed and several constructed for the U.S. Agency for International Development. Built by the SolarX Corporation, they're being installed in remote villages in Guyana, Ecuador, Kenya, and Zimbabwe. The medical system package includes a refrigerator, sterilizer, examination light, two-way radio, and numerous interior and exterior lights, all powered from the sun. Researchers at NASA's Jet Propulsion Laboratory, working in conjunction with scientists from the University of Southern California, are applying space-related computerized image analysis techniques to the earthly treatment of arteriosclerosis and stenosis of the arteries, diseases that affect thousands of Americans. To calculate the degree of disease present, the computer first indicates the edges of the artery with black lines. The white lines, which just appeared, are the computer's best estimate of where the walls of the artery would be if there were no disease present. Using these guidelines, statistics, such as the degree of narrowing, can be computed and printed out for the patient's file. These same techniques were used to enhance significant areas of the planet Saturn for scientific study from pictures taken by the Voyager spacecraft. NASA's Aeronautical Research and Technology program continues to make contributions across a broad spectrum of aviation. Case in point, the Rotor Systems Research Aircraft, or RSRA, being flown at the Ames Research Center. This unique flying laboratory looks like a cross between an airplane and a helicopter and can fly like both. The main objectives of the research are to flight test advanced rotor concepts to increase performance, lower noise and vibrations, and improve flight control systems. The RSRA is a valuable tool for testing out new rotor concepts. The Bell XV-15 is another research aircraft that holds great promise for both military and civilian use. It can hover like a helicopter or cruise like a turboprop airplane. Once the 25-foot prop rotors are rotated forward, it can fly at speeds up to 350 miles per hour. The XV-15 flew proof of concept and extensive operational demonstration flights for the military in 1982, including the ones shown here for the Navy. After practicing carrier takeoffs and landings at the Navy's North Island base in San Diego, the tilt rotor went through sea trials on the USS Tripoli. The XV-15 is generating a lot of interest for use in search and rescue operations, as an economical way to supply offshore oil rigs, and as an intercity transport. A wind tunnel at the Lewis Research Center in Cleveland is one of the places research is being done to design highly efficient propellers for future aircraft. The unusually shaped propeller has many blades, which spin at speeds greater than those of conventional props. When applied to commercial transport aircraft, researchers believe it will result in fuel savings of as much as 30% over conventional turbofan-powered planes, while operating at similar speeds and altitudes. The Lewis Center also has an icing research tunnel to study problems associated with aircraft flying into conditions that cause ice to build on plane surfaces. The main objective is to provide for more efficient, more lightweight ice protection systems that can be applied to general aviation aircraft, helicopters, and future commercial transports. They called it Salute to NASA Aeronautics, and it was the theme for the 1982 Experimental Aircraft Association National Convention in Oshkosh, Wisconsin. NASA's Langley, Lewis, and Ames research centers participated in the 8-day event with people and equipment. Highlighted at the world's largest annual aviation convention were NASA's research and advanced technology developments in civil, military, and general aviation. 600,000 people saw NASA pilot Tom McMurtry from the Dryden Flight Research Facility put the oblique wing AD-1 airplane through its paces. The pivoted wing of the AD-1 can be rotated to an oblique angle of up to 60 degrees, a maneuver that reduces air drag to increase speed and range without using more fuel. Visitors were treated to an endless variety of aircraft, from home-builts to vintage World War II bombers and fighters, as more than 10,000 planes flew in and out of Whitman Field in Oshkosh during the convention.
That's NASA's 1982 as seen by the eye of the camera. Please join us for our next and final show in this series, 25 Years of Progress. We will cover NASA activities in 1983. I'm Lynn Bondurant.
Looking good. Roger, Columbia on a roll. Columbia, Houston, your go at 40.